going to go on to the next topic, which is still in Chapter 4 in your textbook. It's Inequalities. Chapter 4, Section 4. I'm on page 1 of your new packet. In the textbook, it starts on page 220. You've talked about inequalities before in the past using the symbols greater than and less than. You also know that not greater than means not greater than, and the symbol less than with the slash through it means not less than. Take a look at some other symbols that you can find in inequalities. Greater than or equal to, it's got that little equal line, means greater than or equal to. Less than or equal to means less than or equal to. And not equal to. You know that this is the graph of what numbers n are greater than 6. You've seen this before. It's an open circle at 6, and the line goes pointing towards the right because numbers right of 6 are greater than 6. The circle at 6 is not shaded in or not filled in. It's called an open circle because 6 is not included. The graph of what numbers n is greater than or equal to 6 is similar, but now the circle is filled in. So this is the filled in dot, meaning 6 is included in the solution. 6 and anything greater than 6 is greater than or equal to 6. So the 6 is filled in. The next graph shows you the graph of what numbers n are not equal to 6. Every number except 6 is included. So again, open circle at 6. This time the graph goes in both directions. So all numbers except 6 are not equal to 6. So the first direction that we have here says graph the solution. And you may or may not remember this from last year. When you're graphing the solution, what answers, because it's not just one, it's infinitely many answers. Infinitely many answers with an inequality. Not always, but most times you're going to see that infinitely many answers are possible. So number 1 says, what numbers n are greater than or equal to 5? So you need to give yourself a number line, which I already drew a line here. I'm going to put arrows on it. What numbers are greater than or equal to 5? I'm going to put my 5, kind of in the middle. Common Core requires that you show at least one number to the left and the right of it. So one number smaller, one number greater. So what numbers n are greater than or equal to 5? Since it's got that equal symbol, I'm going to fill in the dot at 5. And my arrow is going to point to the, and I make it really big here and make it point to the right because 5 and 5.1 and 6 and 10 and 130 and 1 million and all those infinitely many numbers are larger than 5. So my graph is showing all the things that are greater than 5. Number 2 says, what numbers y are less than or equal to 7? So I give myself a number line. I'm going to put my 7 somewhat in the middle. I have to show at least one number greater and one number lesser than 7. Less than or equal to 7, this graph would be, again, a filled in dot, and it would point to the left. So all the numbers that are less than 7 are to the left of 7, like 6.99999. And 5 and 0 and negative 23 and negative 4,136 and so on and so on. Infinitely many answers. The inequality x is not equal to 24, or what numbers x are not equal to 24? Well, again, I'm going to put my 24 in the center of my number line, and I'm going to evenly space one number to the left, which is 23, less than 24, one number to the right, which is 25. What numbers are not equal to 24? Well, all numbers except 24. So open circle at 24, and now my arrows point in both directions because all numbers except 24 are not equal to 24. What numbers b, number 4, are greater than 11 and a half? Well, I'm going to give myself a number line. 11.5 is going to be in the center. I can choose to count by halves and give myself 11, which is half less than 11.5, and 12, which is a half greater than 11.5. So what numbers B are greater than 11.5? Open circle, and greater than points to the right. So any numbers that are right of 11.5 on my number line, the way that I've numbered it, are greater. So 12, 12.5, 13 and 1/10, 66 and 4/10, 107, and so on and so on. Those are the kinds of numbers that are greater, or in the solution of what numbers are greater than 11.5. Now I have an inequality which I'm going to solve. It says not equal to 5. I'm going to solve it like it's an equation. Same steps. I'm going to add 1 to both sides first, because I got to get y by itself. So I have 2y is not equal to 6 when I add 1. Divide by 2, divide by 2, and I get what numbers y are not equal to 3. So it looks very much like the graph above. In number 3 there, I'm going to put 3 in the center, one number to the left, one number to the right of it. What numbers are not equal to 3? Well, all numbers except 3. So I'm going to go in both directions, open circle at 3. Number 6. What numbers n, when divided by 4, are less than or equal to 7? Less than or equal to 7. Well, it's a divide inequality, so I'm going to multiply on both sides by 4. My 4's cancel, and I get what numbers n are less than or equal to 28. So 28 goes in the center of my number line, which needs arrows. One number to the left would be 27. One number to the right would be 29. Hey, maybe I don't want to count by ones. Maybe I want my number line to count by twos. I could do that. So I could put 28 in the center and count by twos and say 30 to the right and 26. And now my number line is counting by twos. That's perfectly fine. Don't have to count by ones. So what numbers n are less than or equal to 28? Less than or equal to requires a filled-in dot because 28 is equal to 28. And less would be to the left, less left. And the symbol kind of points to the left. So I know that I'm going in the right direction because it matches my symbol there. So 26 and 24 and 23 and 19 are numbers that are less than or equal to 28, which would make that inequality a true solution. Some equivalent verbal phrases, because we're going to be changing, and this is on page 235, you can see in your text. We're going to be changing some English verbal phrases to the matching inequality symbol. So things that mean greater than or equal to, at least, no less than, greater than or equal to. Words in English that mean less than or equal to, no more than, at most. So you could have at most $30, let's say, which means you can't have any more than $30. You can have 29 and 28 and 27. Things that mean greater than, well, greater than, more than. Words that mean less than, lesser than. So we're going to be looking for these phrases as we come to inequality word problems. Page 2, please, in your packet. I'm just going to do like every other one on this page, and then we'll complete the rest of those in class. Tell whether each inequality is true or false. So number 1 says -5 plus 2 is less than -2. Is that true or false? Well, I'm going to combine my like terms. -5 plus 2. Well, that gives me -3. -3 is less than -2. Is that true? Yes, that's true. Number 4 here. I've got some order of operations to do. So 3 times -5, that's -15, plus 1. Is that greater than -2 times -6? That's 12. Take away 18. Okay, -15 plus 1, no, that's -14. Is that greater than 12 take away 18? 12 take away 18, or 12 minus 18, would give me -6. Is -14 greater than -6? No, that is false. -14 is less than -6. Write each inequality as a word sentence. So we have the math given to us, write it out in English. So 2 1/2, 2 1/2, 2 1/2 is greater than, that's the greater than symbol, is greater than, I could have said is more than, m. 2 1/2 is greater than m. That's what this mathematical inequality says in English. Number 13. Oh, that's the absolute value symbol. The absolute value of x. So what number's absolute value of x is greater than, the absolute value of x is greater than or equal to, it's got both parts there, greater than or equal to 2. What number's x absolute value is greater than or equal to 2? The absolute value of x is greater than or equal to 2. That's what it's asking you. Number 15 says 72 is greater than or equal to g. 72, 70-2 is greater than or equal to g. Greater than or equal to g. 72 is greater than or equal to, what number is g, basically? So 72 is greater than 71, 70, 69, 50, 14, -5. So infinitely many answers that 72 is greater than or equal to. Number 16 says state an inequality for each graph. Well, I'm going to skip down to number 17 since I'm doing every other one. And it's hard to see this one, but this is what the graph looks like. It's saying what numbers x, m, k, q, whatever letter you want to use, are less than or equal to, that was a filled in dot there. So what numbers k are less than or equal to 2 would match that graph. This is the inequality that matches it. And lastly, graph each inequality on a number line. What numbers x are less than 7? So I'm going to put 7 in the center, or approximately in the center. You could take out a ruler and maybe make your tick marks nice and evenly spaced, maybe a centimeter apart, or eye it, you know, and get them as close to being equally apart as you can, so evenly spaced. So what numbers x are less than 7? Well, 6 and 5 and 4 and 3 and negatives and -1,000 and -1,000,000 and so on and so forth. Open circle at 7 because it's just the less than. That's it for today. We're going to work on some more things on page 2 and continue in our packets tomorrow.